Okay, so for this video, we are going to discuss the questions from May-June 2022, paper 6, the probability and statistics 2, variance 6.3. Okay, so let us start with the question number 1. Alright, so for question number 1, they give us the number of characters in emails by a particular company is modeled by normal distribution. So you can see that it is normally distributed, and then they want us to find the probability that the mean number. So the keyword will be about the mean number, which means that they will want us to find the probability which is related to the sample mean. Okay, so the mean number of characters in a random sample of 100 emails sent by the company is more than 1,300. So we know that this is a sampling distribution. Therefore, we have to find out the distribution for the sample mean. So for the sample mean, original population is normal distributed. Therefore, the sample mean is also normally distributed. Okay, so the mean for the sample mean will be the same as the population mean, which is 1250. And the variance for the sample mean will be the original variance from the population, and we need to divide it by n. So the n here in this case will be 100, the sample size, and after that I will get the variance for the sample mean, which is 2304. Okay, and now we want to find out the probability. So find out the probability that the mean number, which is the sample mean, is more than, so the keyword here is more than 1,300. So it will be more than 1,300. All right, so from the from what we write just now, right, we already know that the sampling distribution is normally distributed. Therefore, we have to change it become the Z, okay, to find out the probability. All right, so we have to change it, which means that we standardize it. So how to standardize it? You have to take the original value minus the mean. So the mean here is 1250 divided by standard deviation over square root n. So the standard deviation over square root n, generally we already calculate the value from here. So we can straight away take the square root of 2304. Alright, so we can try to get the probability. So Z greater than 1.042. And then to find out this value, we have to take 1 minus the probability that I get it from the table. Because from table, they will give us all the value which is smaller than, right? Okay, so I want to find out the probability where I take 1 minus this probability from the table. So we are looking for Z smaller than 1.042. So where will be the 1.042? Okay, so this is 1.0, and then we look at the 4. All right, so this is what we have, and then let us have a 2 here and see what is the digit that we have to add. So we have to add a 5 at the last digit here, which is become 0.8513. Therefore, for our steps here, I will need to minus 1 minus, we have to take 1 minus 0.8513. And we'll get 0.1487, or we will change it become 3 significant figure where it is 0.149. Okay, so this is how we solve question number 1. Okay, so question number 2. Anton believes that 10% of the students at his college are left-handed, 10% of them. Okay, so Aliyah believed that this is an underestimate. So underestimate is actually the keyword to help us to form the alternative hypothesis. All right, so she plans to carry out a hypothesis test where the null hypothesis is p equals to 0.1 against the alternative hypothesis, which is p greater than 0.1. Okay, and then she chose a random sample of 20 students from the college, and she will reject the null hypothesis if at least 5 of these students are left-handed. Okay, so first they want us to explain what is meant by a type 1 error in this context. So we should try to define the definition for type 1 error by using the context for this question. Okay, so type 1 error generally means that we reject the null hypothesis when the null hypothesis is true. Okay, therefore, where's the meaning of reject the null hypothesis in our example here, in our question here? So reject null hypothesis means that we accept the alternative. Accept the alternative means that this is correct, where the proportion of the left-handed should be more than 0.1. So we should tell them in this way, where we try to accept, okay, the statement that more than 10% of the college students, more than 10% of the students in the college are left-handed. Okay, so we conclude that, okay, more than 10% of the college students are left-handed, but in fact, it is not true. Okay, so although it is not true. Okay, or you can write, you can also write, although in fact, the real proportion is not more than 10% or 0.1. Okay, also can, right? So that's the meaning where you have to try to explain the meaning of the Taiwan error, okay, by using the context of the question. Okay, so this is what we have for part A. All right, so for part B, they want us to find the probability of a type 1 error in the test. Okay, so to get the type 1 error, this is the definition for type 1 error, right? We need to have the reject null hypothesis. So reject null hypothesis means that we have to find out the rejection region. Okay, so to get the rejection region, let's have a look for this last sentence here. So this last sentence mentioned that she will reject the null hypothesis if at least 5, okay, at least 5 of these students are left-handed. So if let's say X is the number of students, at least 5 of them is X greater equals to 5 are left-handed. And this is actually my rejection region, because when X is greater or equals to 5, she will reject the null hypothesis. Okay, so from this sentence, we are getting one important information where X greater equals to 5 is actually the rejection region. All right, and now we are going to use the rejection region to calculate the probability for type 1 error. Okay, so let's continue from here. Okay, to calculate the probability of type 1 error, generally I need rejection region, which is X greater equals to 5, given that the null hypothesis is true. So in the question just now, they already mentioned that the null hypothesis is having P equals to 0.1. Okay, so this is a rejection region. This is when the null hypothesis is true. So to calculate this probability, you should know that for this question, generally the distribution for this question should be binomial distributed. All right, so we are having 20. Okay, so 20 students as a sample. We can have a look here. 20 students as a sample. And then the left-handed probability is 0.1. All right, so that means when we want to calculate the type 1 error, you have to use the binomial distribution and calculate the probability. So x greater equals to 5, it is too long. If let's say I want to start from x equals to 5, x equals to 6, until x equals to 20. Therefore, I have to take 1 minus x equals to 0, 1, 2, 3, and 4. Right, so for binomial distribution, when x equals to 0, it will be 20 C0, 0.1 power 0, and 0.9 power 20. Then you have to minus x equals to 1, where I'm having 20C1, 0.1 power 1, 0.9 power 19. Okay, so we have to minus from x equals to 0 until x equals to 4 by using the binomial formula. Okay, and we are having 20C4 here. Okay, so if we didn't do any careless mistake, All right, so for this particular question, the answer should be 0.0432, correct to three significant figure. Okay, so this is how we actually calculate the type 1 error for a binomial distribution. Okay, then let's proceed further. Okay, so for next question, they want us to calculate the type 2 error. Okay, so you can see that for type 2 error, right, when they want us to calculate the type 2 error, definitely they will give us a value for the p. All right, it's because of for type 2 error, the definition is we accept the null hypothesis when the null hypothesis is false. So if null hypothesis is false, means that the p is no longer equals to 0.1. This is wrong. Okay, and we accept when null hypothesis is false, that means that there's a possibility that the p is greater than 0.1. So when p greater than 0.1, it can be many different values, which is 0.2, 0.3, and so on. Therefore, the question will definitely give us a new value for the p. So we are going to use this p equals to 0.3 in our calculation for type 2 error. All right, okay, so let's start. So for type 2 error, the definition is accept the null hypothesis when the null hypothesis is false. So type 2 error. All right, so for accept null hypothesis, generally I need acceptance region. Okay, so from the question, I already get the rejection region, which is x greater equals to 5. So acceptance region will be actually the complement of this set, this data, right? So x greater equals to 5, the opposite meaning, or the complement of x greater equals to 5 will be x smaller than 5. Therefore, in our calculation for acceptance region, I will need to include x smaller than 5. This is my acceptance region. And given that the probability now is not 0.1 anymore, it becomes 0.3. Okay, all right. So again, I need to identify what is the distribution for this question. So for type 2 error, now it is still binomial distributed. The sample size is still 20, and the new value for the p is 0.3. All right, so once you identify the distribution already, then we can start the calculation for the probability. X smaller than 5 means that you can start from x equals to 0 until x equals to 4. So again, binomial distribution, x equals to 0 means 20C0, 0.3 power 0, 0.7 power 20. And x equals to 1, 20C1, 0.3 power 1, 0.7 power 19, and so on. Okay, x equals to 2, x equals to 3, and also x equals to 4. All right, and after that, from here, try to use the calculator and help us to get the answer. So correct to three significant figure, the answer should be 0.238. That's all for the question number 2. Okay, so we come to question number 3. So batteries of type A are known to have a mean life of 150 hours. It is required to test whether a new type of battery has a shorter mean life. So the keyword is shorter to help us to form the alternative hypothesis. Give a reason for using a sample rather than the whole population in carrying out this test. So usually when we carry out the test and we are not going to use the whole sample, we usually use we are not going to use the whole population. Usually we only use sample. The reason is because of if you want to cover the whole population, right, the cost is too high. All right, so you can write one of the reason is either the cost is too high, or you can also say that for the whole population, because the population can be super large. All right, so when you want to carry out the test by using the population, you need a long time, right? Or you can write that it is too time consuming. You can write any one, all right, any reason that's valid, okay, then they will accept it, right? So these two are two of the answer that they will accept. Okay, and now A random sample of 120 type B batteries are tested, and it is found that their mean life is 147 hours. So this 147 hours is actually from the 120 batteries. Therefore, you should know that this is actually a sample mean. Okay, the mean life. So it is a sample mean. And unbiased estimate of the population variance is 225 hours. Now they want us to carry out the test at 2% significance level, okay, whether the battery B has a shorter mean life than the type A battery. So originally the mean life that we expect should be 150 lah. Okay, so when you want to carry out the test, so let us try to set up the null and alternative hypothesis. So first of all, we are having the null hypothesis where the mean life, so maybe I can use a mu. So mu equals to 150 hours. And for the alternative hypothesis, it will be mu smaller than 150 hours because of the keyword shorter than. All right, so we are going to test whether is the mu shorter than 150 hours. Okay, and now first, for this one, generally we should know that it is normally distributed. Okay, the reason is because of we can see that the sample size is large. All right, so the sample size is large. Okay, and then we are having the unbiased estimate of the population variance as well. Okay, so when the sample size is large, according to the central limit theorem, right? Okay, our sampling distribution will be approximately normal distributed. Okay, so to carry out this test, we can use critical value approach, or you can also use the p-value approach. So for me, I'm going to use the critical value approach. So for the next step, what I want to do is I will try to find out the critical value. And usually for me, I will try to sketch a graph for the critical value as well. Right, so this is a one-tail test on the left. Therefore, my rejection region will be on the left-hand side. And this particular value will be my critical value. Where to get this critical value, of course, I need to know how big is the area here. This area is actually 0.02, which is the 2% of the significance level. All right, and we want to find out the critical value. To find the critical value, we have to refer to this large area where you take 1 minus 0.02 and you get 0.98. So we are going to look for 0.98 to get the critical value. Right, so if you have a look for the detail here, okay, where is the 0.98? So we should refer to the probability and to find out the value of Z. Okay, so try to look for a value, a probability smaller than 0.98 but very close to it. So I think we can see this one. 9798 is close to 98, right? Okay, so the answer is Z equals to Z is equals to 2.0, and then the value on top here will be equals to what's the value? 5, right? Yeah, 5. So 2.05, and after that 9798, I need to add 2 at the last digit. So if I want to add 2 at the last digit, there are two options that you can use here. You can either put 2.054 or 2.055 as your answer. Okay, so let's continue from here. The critical value can be 2.054 or 2.055, up to you. So maybe I will put 2.055, and because of for this particular area and diagram, right, you can see that it is actually on the left hand side, okay, of the center. The center is a 0. All right, so for this part, it should be a negative value, where my critical value should be negative 2.055. Okay, and after I get the critical value, next I will want to calculate the test statistic. All right, so to get the test statistic, the formula is sample mean. So what is my sample mean here? It should be 147, like what I mentioned just now. That will be the sample mean minus the population mean divided by the standard deviation over square root n. So we don't have the standard deviation, we only have the variance, which is 225. So I will take square root 225 divided by the sample size, which is 120. So if I try to simplify everything here, I will get a test statistic, which is equal to negative 2.191. Alright, so now I'm trying to put in the negative 2.191 into my diagram here. So it should be smaller than negative 2.055, right? So that means the negative 2.191 should place somewhere here. And you can see that for this particular line, it actually is fall under the rejection region. Okay, therefore, we can make a conclusion that we are going to reject the null hypothesis for this test. Right, so before I reject it, I will write out the statement to verify it. Okay, so since the test statistic negative 2.191 is actually smaller than the critical value, which is negative 2.055. Okay, so again from the diagram you can see also very clearly that the negative 2.191 is falls under the rejection region. Therefore, we reject the null hypothesis. And what is the conclusion when we reject the null hypothesis? So it actually shows that there's enough evidence to show that the mean life, okay, to show that the type B battery have a shorter mean life. All right. So this is how we carry out the test completely. Okay. All right. Then now we can proceed to part C. Okay, so for part C, they want us to calculate the 94% confidence interval for the population mean for type B batteries. Okay, so to get the 94% confidence interval, all right, the formula generally will be for the limit, it should be sample mean plus minus z, and then multiply with sigma over square root n. Okay, so now let us put in all the important values here. So the sample mean for this case will be 147 minus the z. Okay, so to get the value for z, you are referring to the probability of 0.97, where this is 0.94, this will be 0.03, and this will be 0.03. So to get the value of z, here you should refer to the probability of 0.97. Okay, so again, let us refer to the normal distribution table. Where is 0.97? So you look for the probability part. The probability should be get very close to 0.97, which is this one, 9699. So you can see that it is 1.8. The value on top is an 8. Okay, then you have to add a 1 at the last digit, right? So to add a 1, you can have the value 1.881 or 1.882. Okay, so when you try to put in the value of z here, you can put in 1.881 or 1.882. Both are correct, right? So I will put in 1.881. Then the sigma will be the square root of 225 over n. N is a sample size, which is 120. So the same thing happens for the upper limit, but it becomes plus. Alright, then if we didn't do any careless mistake, when we try to press the calculator, we'll get a long value. And we can correct it to 3 significant figures where the answer should look something like this, which is 144 and 150. Correct to three significant figures. Okay, so this is how we solve question number 3. Okay, so let's discuss question number 4. Each box of seeds and raisins contain S gram of seeds and also R grams of raisins. The weight of a box, which is the B, okay, when empty is B grams, all right? So S R B are independent random variable, so they are generally, all of them are normally distributed respectively, okay? So a full box of seeds and raisins is chosen at random. Okay, so find the probability that the total weight of the box and the content is more than 500 grams. Okay, so first let's define what is the meaning of total weight first. So the total weight means that the weight of the box plus the weight of the seed plus the weight of the raisins. Okay, each of them are normally distributed. Therefore, when you add them together, they are also normally distributed for the total weight. Okay, so to get the total weight, we will need to add all the mean together, which is 300 plus 200 plus 15. And therefore, I get a mean. It should be the value 515. And to get the variance, because this is the sum of the random variable, therefore we just try to add on all the variance together. So 45 plus 25 plus 4. And for this case, our variance should be equals to 74. Okay, and now they want us to calculate the probability that the total weight, so the total weight means B, S, and R, is more than 500 grams, so more than 500. All right, so from our calculation just now, we know that the total weight is normally distributed. Therefore, to calculate the probability, I need to change this total weight become the z-score or z-value. Okay, so how to change it become z-value? So again, you need to standardize it. You minus the mean, where the mean now is 515, divided by standard deviation, where the standard deviation is square root 74. Okay, so we are having square root 74. Okay, the z-value that we get in this case will be negative 1.744. So the area of negative 1.744 is actually equal to smaller than 1.744, right? Positive sign. Okay, so we try to find out the probability from the z value, 1.744. Okay, so let me erase all this first. So we should look for 1.74. The value that we get is this one. And then 4 again. So the 4 here, I need to add the 4 at the last digit. So 9591 plus 4, you get 9595. Therefore, in our calculation, we will have 0.9595 from the normal distribution table. And for us, we will try to correct it to three significant figures, where the answer should be 0.960. Okay, so this is my answer for part A. All right, then now we can proceed to part B. Okay, so for part B, they are saying that the probability, they want to find the probability that the weight of seeds in the box is less than 1.4 times the weight of raisins in the box. Okay, so to translate this whole sentence into a symbol, right, they want us to calculate the probability where the weight of seeds, which is the S, less than, so smaller than, 1.4 times the weight of raisin. So it should be 1.4 times of raisin. This is the probability that they want us to find out. Okay, so before we can find it out, right, we have to actually get the distribution for S minus 1.4R first. Okay, so what will happen if I'm having S minus 1.4R? S and R are both normally distributed. Therefore, when I have S minus 1.4R, it is a linear combination of the random variable where they will be still normally distributed. Okay, for the mean, I need to take the mean for S, which is 300, minus 1.4 times of the mean for the R, which is 200, and I will get the new mean, which is 20 for this variable. Okay, and then for the variance, you need to take 45, the variance for S. There's no minus in variance, you should get a plus. It should be a plus. And then when I want to take out the constant term, all right, from any random variable, 1.4, I have to square it. So I have to square the 1.4. Then only I multiply it with the variance of R, which is 25. From here, I will get the variance, which is equals to 94. So once I get the mean and also the variance, then now I can start the calculation, okay, for the S smaller than 1.4R. So again, first step, you try to move the 1.4R to one side so that you gather all the variable at one side. Okay, so since we know that this is normally distributed, therefore you have to change it become Z. How to change it become Z? You have to standardize it. So you are taking 0 minus the mean, so minus 20 divided by standard deviation. So my variance is 94. Standard deviation will be square root 94. Okay, so after I standardize it, I will get the Z value, which is smaller than negative 2.063. Okay, so to get the probability for Z smaller than negative 2.063, I have to take 1 minus, okay, the Z smaller than 2.063. So again, let's have a look for the table, 2.063. So where is my 2.0? This is the 2.0, 6 will be here, and 3 will be this one. That means I have to add one unit to the last digit. 9803 will become 9804. So I will have 1 minus 0.9804. And eventually the answer that I get is in 3 significant figure. It should be equals to 0.0196. Alright, so this is how we solve question number 5. We have the number of clients who arrive at the information desk has a Poisson distribution. So this is a keyword Poisson. And then the mean is 2.2 per 5-minute period. And they want us to find the probability that in a chosen 15 minutes period, then exactly 6 clients arrive at the desk. Right, so first we already know that this is a Poisson distribution. Therefore, to calculate the probability, we need to modify the mean to the correct interval. All right, so it is originally 2.2 per 5 minutes interval, and now we are having 15 minutes period. Therefore, the lambda or the mean will become 2.2 multiplied with 3, because we are having 15 minutes, which is 3 times of 5 minutes. All right, so we are having 6.6. Okay, so this is a mean for the 15 minutes period. Then now we are going to look for the probability that x equals to 6, exactly 6 clients. So exactly 6 clients, the formula will be e negative lambda, which is 6.6, then lambda power 6 divided by 6 factorial. Okay, so by pressing calculator and correct your answer into 3 significant figure, the answer for this question should be 0.156. So this is what we have for part A. And now let's continue to part B. So for part B, they are saying that if more than 4 clients arrive at a 5-minute period, they cannot all be served. That means more than 4 clients cannot be served and cannot all be served already. Okay, so find the probability that during a randomly chosen 5-minute period, so still the same interval, 5 minutes and 5 minutes, not all the clients who arrive at the desk can be served. Okay, so again, we come back to the 5-minute period. So we are having the Poisson distributed with the mean, which is equals to 2.2. All right, this is for 5 minutes one. And then since not all the clients who arrive at the desk can be served, it means that the number of clients arrive is more than 4. Okay, so to calculate the probability for x greater than 4, you can start with x equals to 5, x equals to 6, until x equals to infinity, where this is impossible for us to list out everything. So we will take 1 minus the probability of x smaller equals to 4. Okay, so to get the probability for this one, we are having e in negative lambda, which is negative 2.2. When x equals to 0, the remaining term is 1. When x equals to 1, the term is 2.2, which is the lambda. When x equals to 2, it will be 2.2 squared divided by 2 factorial. When x equals to 3, it will be 2.2 power 3 divided by 3 factorial. And again, we need to include the x equals to 4 in our calculation. Therefore, I will have 2.2 power 4 divided by 4 factorial. And we should stop here for x equals to 4. And again, if you try to press calculator without any careless mistake, then the 3 significant answer for this question should be 0.0725. Okay, so this is what we have for part B. Now let's proceed to part number C. Okay, so for part number C, they are asking for the suitable approximation, suitable approximating distribution. Okay, to find the probability that during a random chosen 1 hour period, so now the interval become 1 hour, fewer than 20 clients arrive at the desk. So first of all, definitely we need to change out the mean, become 1 hour one. So it will be 2.2 for 5 minutes. Therefore, for 1 hour, it will be 12 times of 5 minutes period. Therefore, I have to multiply with 12. When I take 2.2 multiplied with 12, I'll get 26.4. Okay, due to the reason that the lambda now is more than 15, therefore we can change it become normal distribution from a Poisson. To get the normal distribution mean, it is actually the lambda for Poisson. To get the variance for the normal distribution, it will be also the lambda for Poisson. Because Poisson has a special characteristic where the mean and variance are having the same value. Alright, so just for your information, this is the lambda from Poisson. This is also the lambda from Poisson. And we change it become normal because of the lambda is more than 15. Alright, after we change it become a normal distribution, we want to calculate the probability where fewer than 20 clients arrive. So we are looking for x smaller than 20. For Poisson distribution, it is discrete random variable, and then for the normal distribution, it is continuous random variable. Therefore, when you are changing from change the discrete to a continuous random variable, we need to apply continuity correction. So for the continuity correction, for this case, smaller than 20, it should be smaller than 19.5 after the adjustment. And after you change it, after you have the continuity correction already, to find the probability, you have to standardize the variable to change it become z, where we are having the value of x minus the mean, where I should minus 26.4, divided by standard deviation, where I should divide it by square root 26.4, because 26.4 is the variance, right? Okay, then get the value of z here. The value of z is negative 1.343. And this area is equals to 1 minus z smaller than 1.343. So to get the probability for z smaller than 1.343, we'll look for 1.3 and then 4, 1.34 and then 3. This one. That means we have to add a 5. We have to add a 5 at the last digit of this. So when I add 5 at the last digit of 9099, I will get 9104. So I will take 1 minus 0.9104. And from here, I will get a 3 significant figure answer where it should be equals to 0.0896. Okay, so this is how we solve part C for this question. Then now we continue to next part, right? Oh, there's part C only, no more next part for question number 5. All right, so this is how we solve the question number 5. All right, so now we are at question number 6. Okay, so they give us a random sample of 5 values, and then all these are the values are 2, 3, 3, 5, 8. Find an expression in terms of A for the mean of these values. All right, so to get the expression in terms of A for the mean, right? Generally, what we have is the mean, sample mean is equals to summation of x divided by n. Alright, so as the summation of x, you add all the terms, all the number, or all the data together, which is 2 plus 3 plus 3 plus 5 plus a, divided by how many numbers are there. So there are total 5 numbers here. And eventually, if I try to simplify, I'm having 13 plus a divided by 5. So this is the expression in terms of a that we can get for the to find out the sample mean or to find out the mean. Okay, and then if we continue further to part number B, now they give us another important information where the unbiased estimates for variance is 4. And then it is also given that A is positive. They want us to simplify the quadratic equation. And from there, we need to find out the value for A. Okay, so for to recall back now, what is the formula for unbiased estimates variance? So unbiased estimates variance formula will be 1 over n minus 1 and then summation x squared minus the summation x whole thing square divided by the n. So this is the correct formula for the unbiased estimate for the population variance. And now we are going to put in all the values that we know here. So first, the variance is a 4. Therefore, the sigma square is a 4. We are having 5 numbers in total in the set of data. So n is equals to 5. 5 and minus 1 become a 4. Summation of x squared. So for the summation of x squared, generally we need to square all the x here and then add them together. So we are having 2 square plus 3 square plus 3 square plus 5 square plus a square. And then we have to minus the summation x squared. So the summation of x generally is equals to 13 plus 8 because this is my summation x in the first part and what we get is this one. This is the summation of x, which is 13 plus a. Therefore, I will take 13 plus a and I square it divided by the n. So divided by the number of data. So by right, this is another equation that we can get up from the information provided here. And now we are trying to simplify everything, or we are trying to form a quadratic equation in terms of a. So I bring the 4 over and I try to add all the values here and I get 47 plus a squared minus 1 over 5. I take it in front first and then I try to expand the 13 plus a squared. So when I expand 13 plus a squared, I'm having 169 plus 26a plus a squared. Okay, so this is what I get for now. And then again, to form a quadratic equation, I multiply the whole equation with 5 so that the denominator disappears. Multiply 16 with 5, I get 80. 47 multiplied with 5, I get 235, and so on. Okay, if I rephrase everything again, from here I think it is quite clear that we already get a quadratic equation in terms of 8. Therefore, to get the value of a, we try to factorize it. Okay, so from here, we'll get two values of a, where a equals to negative 1 over 2, and also a equals to 7. But of course, the question already mentioned that the a is a positive value, right? So we should ignore this negative value of a and accept only the answer where a equals to positive 7. Okay, so this is how we get the quadratic equation and we factorize it to get the value of a. Okay, so question number 7, and we are given the random variable x and also w. Okay, for of the random variable x and w lah, and with the probability density function for each of them. Then first they want us to write down the value for p greater equals to x greater equals to 0. All right, so maybe for us we can try to observe the probability density function first. Okay, as an example for us, if you look at the function f, it is for the variable x, right? Okay, the function is p multiplied with a square minus x square, and the x is from 0 until 8. Okay, so for your information, when we are having a square minus x square, we can actually rewrite it become a minus x and also a plus x, where the negative a and also the positive a is the x-intercept if you wish to sketch the graph out. All right, so as an example, if I try to visualize it, I'm having negative a here, I'm having a positive a here. Okay, so the graph originally should look something like this. It is a x squared, that means it is a parabola, and then negative x squared tells us that should be an N shape instead of U shape. All right, so this is what I can get, and then after that I want to know what is this maximum point here. This maximum point, when x equals to 0, you'll get p a squared, where a is a value, right? Okay, so after I visualize the diagram already, right? Okay, so they are only focused for the part where x is greater than 0 until 8. So this is 0. From 0 until 8 means that they only want us to consider this part of the graph. So to consider this part of the graph, and they are asking for x greater equals to 0, generally it includes the whole area under the graph where it is more than 0. Alright, therefore the probability should be equals to 1. Okay, for any continuous random variable, right, the total area under the graph should be equals to 1. So when x is greater equals to 0, it is already covered the total area under the graph. Therefore, we will make it as the probability equals 1. Alright, so you can straight away out the answer if you can visualize the diagram earlier by yourself. Okay, then now you can go to part number 2. So for part number 2, they want us to write out the value for w greater equals to 0. So let's have a look for the function g, where it is for the variable w. Okay, so for function g, they are similar, very similar to function f, just that the domain defined is slightly different. So the domain defined here will be from negative a until positive a. Okay, so for the same technique, we try to sketch out the diagram for the g. They are actually the same. Okay, just that the domain is different. Therefore, if you want to visualize the whole thing here, your g should look something like this. The x-intercept is also at a and negative a. Okay, so this is a, this is negative a, and definitely this value will be this value should be qa squared, right? So qa squared. All right, so this is for the function w. Just now, what is for the function, the variable x? This is for variable w. Okay, then for this diagram, the area, the domain defined is from negative a until positive a. Therefore, the continuous random variable, the graph will look something like this. If you compare it with the part that we have just now, they are slightly different. For this part, you only start to consider from x equals to 0. Okay, then for this part, we will start from x equals to negative a. Sorry, w from negative a until positive a. So that means this whole area or this whole diagram is the function that they define. Okay, then now they're asking for the probability of w greater equals to 0. So this is 0 also. For w greater equals to 0 means that I only want to consider this area. Alright, my original area is the whole area under this N shape, and now I want to consider only the probability for this area. So for your information, the whole area under the graph should be equals to 1, and this looks like a part or half of the area that we have for the original one is the whole area, whole curve, and then now we are having only like half of the whole curve. Therefore, if I want to write down the probability of w greater equals to 0, so it will be equals to half only. okay, of the whole area 1. So it will be equals to half, or 0.5. Okay, so this is the value that we can write down as the probability by looking at the area under the graph. Okay, then now continue to part 3. So for part 3, they want us to write down the expression for Q in terms of P only. Alright, so if we try to compare the diagram for P and Q, for the P and also for the Q, generally what you can see is like this whole area is already a 1. This area is only the half. Therefore, if you try to compare the value for P and also the value of Q, right? P should have a larger value and Q should have a smaller value. Alright, so compare the area, it is 2 times from graph A compared with graph B. Therefore, the value of P and Q also the same, where Q should be only half of the value of P. Therefore, you can write out Q equals to half the value of P. So the reason is because of P must be larger. The value of P must be larger so that the whole area under the graph can be equals to 1 for this part. Then the value of Q should be half of P so that these 2 parts of the graph equals to the one that we have in part. Okay? Alright, so this is what you have for part C now, part 3. And we can proceed to next question. Okay, so now given that the EX, expected value for X is equals to 3, and they want us to find the value of 8. Okay, so this is a useful information. The expected value of X is equals to 3. We can form one equation from here. Okay, so before that, we can get one important information first from the definition of the continuous random variable, where you try to integrate from negative infinity to positive infinity, right? For the function, you should get the probability or the area equals to 1. Okay, so this is the first information that we are going to use now, okay, to form one equation. Right, so you have a look for the function fx. Function fx is this one. We are having 2 unknown here, like p and a. Alright, therefore we need this, we have to apply it here to get the first equation for p and a first. Right, so the integration will be integrate from 0 until a for the function p a square minus x square dx, and I let it equals to 1. P square is a constant, therefore I just copy it, and then a square, just copy, integration will become a square x minus x power 3 divided by 3 factorial, and then, oh sorry, it is not by 3 factorial, it is divided by 3. Okay, then I need to put in the limit for a and 0. Okay, when I substitute the value for a into this equation, I'm having a power 3 minus 1 over 3 a power 3. When you substitute the 0 into the equation or expression, I will get the 0 for the whole thing. Okay, so from here, the very first equation that I can get, or expression that I can get, should be 2 over 3 a, a cubed equals to 1. Alright, then, okay, so I think I made a careless mistake here, right? So here shouldn't be any square, because when I take out the p, it should be remain as a p. Alright, so because later I know that I want to find the value for a, so I will make p as a main object for main side of the equation. So I'm having 3 over 2a power 3. This will be my first equation that I get. Alright, and second equation, I will form it by using this information. The expected value of x should be equals to 3. Okay, so to have the expected value equals to 3, right? The information that we are using is we integrate from negative infinity to positive infinity, and then you have to multiply the x into the function. Then this is your expected value. So we are going to apply in our equation here. Okay, so to get the expected value, I need to integrate from 0 until a. I multiply the x with the original function fx. and I let it equals to 3. Okay, so again, p is a constant. I will take it out, and I'm having a square x minus x power 3 dx. Okay, so first I try to apply the integration from here. I will have a square, the power x plus 1 become 2 divided by 2. Then this one is a 4 divided by 4. And then again, I want to substitute a and 0 into the equation. So when I substitute the a into the equation here, I will have a power 4. And this one, I will also have a power 4. When I substitute 0 into the whole expression here, I will get a 0. And I will let it equals to 3. Okay, so simplify this equation, I will have 1 over 4 a power 4. And it is equals to 3. Therefore, from here, I get my second equation, where p is equals to 12 over a power 4. So maybe I can make this as a second equation. Alright, so I'm having equation number 1 and also equation number 2. I can solve them simultaneously to get the value for a. Alright, so I will let equation number 1 equals to equation number 2. So 3 over 2a cubed equals to 12 over a power 4. So if I try to simplify everything here, I will get a equals to 8. Okay, so this is how we solve the question number 7 for this paper. Alright, and this will be the last question for this paper. Thank you very much for watching the video.